This lesson is about the Cartesian coordinate system, more specifically how to plot points and lines. This may look familiar to you. It's the rectangular coordinate system that we use, or more specifically, the Cartesian plane. Whenever the x and y axes are put onto the Cartesian plane, it divides it up into 4 separate spaces that we call quadrants. Normally, we use Roman numerals to show each of these different quadrants, and it works counterclockwise. The top right being quadrant 1, then quadrant 2, quadrant 3, and quadrant 4. Right in the middle, where these axes cross, is the origin. Let's look next at plotting points, or what we refer to as ordered pairs. An ordered pair consists of 2 separate parts, an x-coordinate and a y-coordinate. The x-coordinate is the horizontal direction, the y-coordinate is the vertical direction. For this sample point, x equals 3, which means we're going to move 3 units to the right. In this point, the y-coordinate is -2, so we'll move 2 units down. This gives us the point 3, -2, which happens to lie in quadrant 4. Let's try some other points just to get used to seeing it and review a little bit. So for example, let's look at the point. We'll call it point A, 3, 2. For the point 3, 2, I'm going to start at the origin, move over 3 units, and then up 2 to end up right here. Let's do a few more. Point B, -5, -2. I'd move 5 units to the left and 2 units down. Point C, 0, 4. This is unique. When one of the coordinates is 0, we're going to end up on an axis. This is telling you not to move anywhere in the right or left direction. You just stay right there at the origin. And then we'll move up 4 units. Later on in a subsequent lesson, we're actually going to learn the name of this. This is going to be called a y-intercept because it crosses the y-axis. Now similarly, we could have something like this. The point D, 5, 0. In this case, I'm going to move to the right 5 units, but not anywhere up or down. Just leave it right there. This will be referred to as an x-intercept because it crosses the x-axis. It doesn't even lie in a quadrant, just right on the axis itself. Let's extend this now to actually looking at graphing equations of lines. An equation of lines shows a lot of solutions. In fact, it shows an infinite amount of solutions. All we need to do, though, is at least get 2. Let's go ahead and make a chart to start keeping track of some of these solutions. We want to use some easy points. I mean, after all, most of this is going to be mental math. So a point like 0 works really nicely. If x equals 0, then the corresponding y-coordinate should be 0 plus 3, or 3. This is the point right here. Let me do a few more, like x equals 1. The corresponding y-coordinate for x equals 1 should be 1 plus 3, or 4. Now at this point, I have enough to connect the dots. A line only needs 2 points. But what's really nice is if you can get at least 3. That way you'll know if you made a mistake, if those 3 points don't fall in a line. Let me get one that's back a little ways, maybe -2. If x is -2, -2 plus 3 is 1. You can see my points all fall in a line. To finish this, I'm going to go ahead and create a line. So we want to make sure the line goes through all 3 of those points. In fact, there's a lot of other dots that we didn't find that must be on this line. For example, the point -3, 0 is on this line. If we substitute -3 into the table, -3 plus 3 is 0, and you can see that's exactly where it falls. So this line is representing all of the solutions, all the ones that we can't see, even the ones with decimal places, that will fulfill the equation y equals x plus 3. Let's try another one. I want to go ahead and make the chart. And we start substituting in some numbers. Again, choose things that are easy to do, like 0, for instance. 2 times 0 plus 1 is 1. I'll use the point 1. 2 times 1 plus 1. Now that's enough, but let me keep going just to see if this is done correctly. 2 times 2 plus 1. This should do it. Let me go ahead and plot the line then that goes through these points. There it is. The graph of the equation y equals 2x plus 1. Let's do one more. This one is a fraction, so it's just a little bit more difficult to do the mental math. It's going to be even more important to choose x values that are easy to do. So for this one, I'll choose 0 first. Negative a half times 0 is 0, and then plus 3 is 3. But if you notice, if I use the next number 1, I'm going to get a fraction in the answer. Even though this is okay, it's not easy to do. So how about choosing something like this, like maybe the number 2? I'll do the arithmetic here for you. Negative 1/2 times 2 plus 3. You notice the 2's cancel. And what I get is negative 1 plus 3, or 2. So just by choosing a particular value, you can make the arithmetic easier for yourself. Same thing with the number 4. I'm trying to think of numbers that'll cancel nicely with that half. 2 and 4 reduce to the number 2. So I'll have negative 1 times 2, or negative 2, plus 3, which equals 1. That's enough to do it. Let me plot the line that goes through these points now. There we go, the graph of negative 1/2 x plus 3. A quick table of values is the easiest way to graph equations in the form y equals.